Here are some flashcards for the AP Statistics exam. You need to have all of these memorized if you want to get a 5 on AP Stats. So all of these flashcards are about probability. So the first one says mean and standard deviation of a binomial distribution. So these are formulas. You need to know that the mean, mu of x, is n times p. And the standard deviation, sigma of x, is equal to the square root of n times p times 1 minus p, where n is the trials and p is the probability of success. Remember, on Desmos, you can simply go to add an inference and go to a binomial distribution, type in n and p, and it will give you the answers for you. Mean and standard deviation of a geometric distribution. So the mean, mu of x, is equal to 1 over p, and the standard deviation, sigma of x, is equal to the square root of 1 minus p over p. These are the probability of success. Again, if you go onto Desmos, go to add an inference, and you look at the probability distributions, go down to geometric, you'll be able to use that to solve that probability. Formula for the binomial probability of x is equal to x. Okay, this is the formula. This formula is, I believe, on your formula chart. I would not memorize this formula. I would instead know how to do this on the calculator. And again, since this is a binomial probability, you just go to the add inferences on Desmos and click on binomial probability. Formula for the geometric probability. Okay, again, this is the formula for geometric. Should be on your formula chart. I would just know that if I go on to Desmos and then I go to add an inference, I can click on geometric probability to solve and get my answers. Next, conditions for a binomial random variable. For a binomial random variable, we have to remember the acronym BINS, B-I-N-S, binary, independent, number of trials, and same probability. Remember, binary means it has two outcomes. You either have a success or you have a failure. Independent means each trial is independent of the next, which means your first trial doesn't impact your third trial. Number of trials, so you're having a fixed number of trials. You're not doing this continually until you reach success. Same probability for every single one. Okay, next, conditions for a geometric random variable. Okay, this one is bits. Okay, remember, for binomial random, it's bins. For geometric, it's bits. Binary, independent, trials, and same probability. So the only difference here is that instead of number of trials that are fixed, so we're going to do this for 5 trials and stop. We're going to do these trials until we get a success. So that means that trials could be 2 trials, 5 trials, 1,000 trials, how many it takes to get a success. That's the difference between binomial and geometric. Next says, what is the law of large numbers? The law of large numbers states that the empirical probabilities tend to get closer to the true probability as the number of trials increases. Okay, so pretty much the bigger the trials, the better the probability. How do I calculate the probability of at least 1? Okay, remember, the probability of at least 1 is the same as saying 1 minus the probability of nothing. How do I calculate a conditional probability? So this is the formula for conditional. Remember, this is the probability A given B has already happened. So that's the same as saying the probability of A and B, which means we take probability A and add it to probability B, divided by probability B. How can I tell if 2 events are independent? Remember, 2 events are independent if any of the following are true. So any of these formulas can be true. We do not need to check all of them. Just one of them has to be true for this to be independent. Mean and standard deviation of the sum of 2 independent random variables. So if we have more than one independent variable, the mean we simply can add. The standard deviation, however, is always going to add. These formulas are not on the formula chart, so I would make sure at the very least you remember standard deviation, because for standard deviation, it's not simply adding them or subtracting them. It's always going to be the standard deviation of one squared plus the standard deviation of the other squared, and then take the square root of both. Mean and standard deviation of discrete random variables. So this is the mean, mu of x, is equal to the expected of x, which is the summation of x sub I times the probability of x sub I. And standard deviation is the square root of the summation of x sub I minus mu sub x squared times the probability of x sub I. Again, those formulas are on your formula chart. Mean and standard deviation of difference of two independent random variables. Okay, notice that the difference, the mean subtract, but the formulas for difference of standard deviation is the exact same for the sum of them. Look at the two formulas. Notice how they're the same. Standard deviation never subtracts, ever. Formula and interpretation of z-score. Remember, z is equal to the value minus the mean over the standard deviation. A z-score tells us how many standard deviations a value falls away from the mean in what direction. Calculator function to find the area under a normal distribution. So again, this is talking about the TI calculator. If we were asking to find the area under a normal distribution on Desmos, we would go to add an inference, and then click on the normal distribution, and then we would be able to type in any given information to find the area. Calculator function to find a value from a given area under a distribution. So this is different. This one is go on to Desmos, do exactly what I said, add an inference, normal distribution, keep it on area. This one is doing the opposite. So you're going to, look at this for calculator if you need it, but for Desmos, what you're going to do for this is you're going to do the same process, but instead of area, you're going to click on bounds. Okay, put in all the information you have and then get your answer. What is the empirical rule? Empirical rule, remember that 68% of the data is within one standard deviation, 95% is within two, and 99.7% of the data is within 3 standard deviations. So 1, 2, and 3 standard deviations from the mean. What is the difference between binomial PDF and binomial CDF? Okay, the only difference, and this is a good visual for the calculator, but the only difference on Desmos is it tells you which region we're looking at. So if it is a PDF, then it's going to equal that probability. If it's a CDF, then we're going to have some sort of inequality. We're going to have greater than or less than. Okay, mutually exclusive events. 2 events are mutually exclusive if they cannot occur at the same time, which means the probability of them both occurring at the same time is 0. How do I calculate probability of A and B? Well, that's simply using this formula here, the probability of A times the probability of B given A has already happened. And again, I believe this is on your formula chart.